The universe is so vast that even light takes billions of years to cross its observable part. We are just a tiny dot among infinite galaxies, yet it is our curiosity that makes us capable of understanding its grandeur. Stephen Hawking. Friends, this is not just a video, it's a genuine journey, a slow and profound reflection on one simple yet unfathomable question. How big is the universe? We won't be talking about dry figures and statistics, but about something you can experience firsthand. If the universe is truly as immense as scientists claim, if it's expanding at an incredible speed exceeding the speed of light, if it contains trillions of galaxies, each comprising hundreds of billions of stars, and if its age is almost 14 billion years, what does that mean for each of us? How does it affect our lives, our problems, our plans, and even every breath we take? Over the next few minutes, we will journey further and further away from Earth until our minds reach their limits, perhaps even breaking a little along the way. We'll start with ancient stargazers, then move on to the first telescopes in modern science, until we reach the invisible boundaries of the observable universe. But we will also explore the emotional impact of encountering such a scale. For numbers are just cold data, but perspective is a personal perception. Let's pause for a moment and look around. Notice the walls, the furniture, the objects we own, the planet spinning beneath our feet. All of this exists within a galaxy that spins within a filament, stretching across a universe expanding so rapidly that even light cannot keep up. We will trace this path step by step. In the beginning, there was light, but before light, there was silence. So, let our journey begin. In the early 19th century, specifically the first years of that century, the universe still guarded its secrets, not fully revealing its colossal scale. Telescopes, like sharp eyes, improved our vision, but the true distances to stars remained a mystery. How could one measure distances in light years using only knowledge of geometry and boundless patience? This is where Friedrich Bessel, a meticulous German astronomer, enters the scene. Around 1837–1838, he aimed his powerful instrument, the Fraunhofer heliometer, at a faint but fast-moving star known as 61 Cygni. With this precise instrument, he was able to measure the tiny shifts in the star's position caused by Earth's movement in its orbit, an effect known as parallax. Imagine measuring an object so far away that its displacement reflects the movement of a tiny coin viewed from many miles away. Bessel meticulously recorded over 100 careful observations over several seasons. By comparing the star's position with distant background stars, he detected a subtle wobble, just a few hundredths of an arc-second. Based on this data, he calculated a distance of about 10.4 light-years, a stunning achievement. From that moment on, the universe gained its measure. Soon after, other astronomers confirmed stellar distance measurements. Thomas Henderson measured the distance to Alpha Centauri from South Africa, and Wilhelm Struve mapped the position of Vega. However, it was Bessel's parallax measurement of 61 Cygni that firmly placed the cosmic scale in human hands. These were not just dry numbers, it was a true portal. Triangles and perseverance transformed the night sky into a quantifiable realm. Suddenly, distances that once seemed incomprehensible became numbers, still vast, but now accessible to the human mind. This fundamental feat, measuring the distance to a single star, paved the way for astronomers to build longer ladders. From nearby stars, they ventured further, using methods like Cepheids, supernovae, and redshift. Each new rung pushed us deeper into the depths of space, but this was only the beginning. With quiet persistence, Bessel, under the Königsberg sky, defying human intuition, showed the world that cosmic distances could be measured and known, connecting empty space with geometry and unwavering determination. Building on Bessel's groundbreaking discovery, astronomers realized the need for a brighter and more distant ruler to reach galaxies beyond our Milky Way. Cepheids, pulsating beacons whose brightness changes with predictable regularity, became those rulers. Discovered in the late 19th century, these stars pulsate with a period directly related to their intrinsic luminosity. Measure the rate at which they brighten and dim, and you can determine their true brightness. Then, Compare that value to how bright they appear from Earth, and you have their distance. In the 1920s, Edwin Hubble applied this method to unravel a cosmic mystery, the nature of nebulae, such as the Andromeda Nebula. By discovering Cepheids in the Andromeda Nebula and calculating their distance, he proved that these nebulae were not part of our galaxy, but separate galaxies, each containing billions of stars. This discovery meant the universe was far larger than anyone had imagined. It was a true scientific revolution. We moved from knowing the distances to a few nearby stars to measuring the distances to entire galaxies, millions of light years away. Cepheids, with their rhythmic pulsations and predictable luminosity, became the second rung on the cosmic distance ladder, built upon Bessel's initial geometric step. Looking ever deeper into space, we begin to understand that the universe is not just enormous, but also populated by countless cities of stars. Each Cepheid lights its way, tethering distant galaxies to our expanding cosmic map. After Cepheids paved the way to nearby galaxies, astronomers faced a new challenge, measuring distances to galaxies so far away that individual stars within them couldn't be resolved. To solve this, something brighter, something explosive was needed. That something became Type Ia supernovae. These aren't ordinary stars, but rather their detonations. White dwarfs in binary systems accrete matter from their companions until they reach a critical mass. When this limit is exceeded, the star collapses inward and then explodes with unimaginable force. The blast is so bright it can be seen billions of light years away, often outshining an entire galaxy for several weeks. But the most useful aspect is that these explosions have a consistent brightness. Nature, it seems, has provided us with a cosmic flashlight. Because Type Ia supernovae explode under nearly identical conditions, they reach almost the same peak luminosity. This makes them ideal standard candles. Once astronomers determine how bright the explosion should be, they compare that value to how bright it appears from Earth. The difference between these values allows them to determine the distance to the explosion site. The genius of this method is that it vastly expands our capabilities. We are no longer limited to our galactic neighborhood. With these supernovae, we can measure distances to galaxies billions of light years away, galaxies that are too distant and faint for even our most powerful telescopes to resolve in detail. But there's more. These supernovae not only provide us with distance information, but also reveal something deeper about the universe's motion. As astronomers mapped the distances to many of these galaxies, they realized something shocking. The farther a galaxy is, the faster it appears to be moving away from us. This relationship between distance and velocity is the fingerprint of an expanding universe and led to the formulation of Hubble's law. The universe isn't just vast, it's constantly getting bigger. This realization shook the foundations of physics. The cosmos is not static, it is dynamic, stretching, growing, and evolving. Every supernova flash, every measured distance is a note in the grand symphony of the universe's expansion. This part of our journey changes the narrative's tone. We are no longer bound to a finite sky. The universe is not just large, it is becoming even larger. Stars are not fixed on a celestial dome, but are rushing away from each other in a silent, accelerating ballet. For decades, stargazers believed that after the Big Bang, the cosmos would continue to expand. However, the omnipresent force of gravity was expected to slow this process down sooner or later, perhaps even reverse it. There was a logic to this, as any explosion eventually subsides, and any stretch under weight inevitably weakens and sags. But something didn't quite fit the overall picture. When researchers used Type Ia supernovae to determine distances to incredibly distant galaxies and measure their velocities, they encountered a startling discovery. It turned out that the most distant galaxies were not just moving away, but doing so with increasing speed. The farther scientists peered into the cosmic expanse, the faster galaxies seemed to flee, not in a straight line or at a constant speed, but in an unrestrained expansion, as if space itself was tearing apart under the influence of some invisible force. This discovery was a true bolt from the blue. It implied that the universe was not slowing down, but accelerating. But what could be pushing galaxies apart with such rapidity and ever-increasing force? It clearly wasn't gravity or matter. It was something entirely different, something that doesn't clump, doesn't emit light, and doesn't offer resistance. This phenomenon was named dark energy, not because it has anything to do with darkness, but because its true nature remains a mystery to us. Imagine inflating a balloon, expecting its expansion to slow, but instead noticing it stretches faster with each breath you take. This is precisely what dark energy does to space, not just between galaxies, but also between their superclusters, between vast cosmic voids. It doesn't just accelerate galaxies, it creates more and more space between them, making the distances between them truly insurmountable. And the most astonishing thing is that dark energy appears not to weaken or dissipate as the universe expands, but to maintain its power. Moreover, it dominates the universe. According to current astronomical estimates, about 70% of all energy in the cosmos is attributed to this invisible accelerator. Stars, planets, cosmic dust, and everything we can see or touch make up less than 5%. Just imagine, almost all of reality, both in volume and force, consists of something we cannot touch, see, or fully comprehend. And yet, it is this incomprehensible force that determines our destiny. At this stage of our understanding of the cosmos, a deep and unsettling curiosity arises within us. If all objects in the universe are moving away from each other at an ever-increasing speed, what awaits us at the end of this journey? Will galaxies one day vanish from our sight? Will the light of stars be extinguished forever? Will the sky plunge into impenetrable darkness, not due to a lack of luminaries, but due to the irresistible expansion of space? Now, we are measuring not just distance, but destiny itself. Having realized that the universe is not only expanding, but doing so at an accelerating rate, we are confronted with the next equally unsettling question: how will it all end? To even approximate an answer, we must understand the possible shape of space itself. It's easy for us to imagine the universe as a giant balloon or an infinite flat plane, but in reality, space is far more complex than any surface we can draw. Its shape is not just a geometric characteristic, it's a key to our destiny. Scientists studying physics identify three possible shapes for the universe: flat, open, and closed. If the universe is flat, like an infinite sheet of paper, its expansion will continue forever, gradually slowing but never stopping. If it's open, like a saddle curved outwards, it will also expand infinitely, but at a faster rate. However, if the universe is closed, like a sphere, its expansion might one day cease and be replaced by contraction, causing everything to return to its origin, a fiery collapse, or the Big Crunch. For a long time, scientists couldn't determine the exact shape of our world, but thanks to precise measurements of ancient light, which reached us from the distant past in the form of the cosmic microwave background, we have concluded that the universe is incredibly close to a flat shape. It is not perfectly flat, but the deviations are so negligible that, for practical purposes, it can be considered to extend infinitely in all directions. This means it has no edges, no center, only infinite space. However, a flat shape doesn't mean all is well, as the accelerating expansion indicates that this flat universe is governed by dark energy, and this changes everything dramatically. Imagine a universe where, with every passing second, more and more space arises between galaxies, where light itself stretches until it vanishes, and where stars move so far apart they become invisible. In the distant future, entire galaxies will move beyond our cosmic horizon and disappear from view forever. This won't happen because they're moving too fast, but because the space between us is expanding so rapidly that their light can never reach us again. Eventually, only the galaxies closest to us will remain visible, perhaps only those within our local group. The rest will plunge into silent darkness. This possible fate is called heat death, a slow demise in a cold and empty space. No explosions, no collapses, just infinite distance. Every particle moves away from every other particle by such a vast distance that any interaction becomes impossible. Even black holes evaporate, even light fades. It's a destiny marked not by chaos but by complete stillness. However, other theories exist. Some scientists believe that dark energy might intensify, ultimately tearing apart not only galaxies but also stars, planets, and even atoms themselves. This scenario is called the Big Rip. Others believe that dark energy might decay or change direction, creating cycles of expansion and contraction. For now, we don't have a definitive answer. But one thing we know for sure, the shape of the universe and the force tearing it apart are not just speculative concepts, they will determine how time ends. Time, expressed as 13.8 billion years, eludes human comprehension. This concept extends far beyond our everyday experience. When we speak of the birth of the universe, we imagine something akin to an explosion that we might have witnessed had we been in that place at that time. However, it didn't happen at a specific point in space. It was the moment when space itself came into existence. There was no outside observer, no boundary from which it emerged, no before. There was only the fact of its arising. The Big Bang was not an explosion that occurred in space, but an explosion of space itself. Every atom, every particle of matter, every law of physics, everything originated in this colossal flash. In the beginning, there were no stars, no galaxies, not even atoms. There was only a scorching soup of energy, so hot that the human mind cannot imagine it. The entire observable universe, which now spans 93 billion light-years, was once smaller than a grain of sand. And in that grain of sand, time marked its first moments. In less than a fraction of a second, the universe underwent a phase called inflation, a period when it expanded faster than the speed of light. This was not a violation of the laws of physics, as space itself has no speed limit. This inflation determined the scale of the cosmos, smoothed out irregularities, shaped patterns, and turned quantum fluctuations into the seeds of future galaxies. Then came the cooling. In the first 3 minutes, protons and neutrons formed, as well as hydrogen and helium, the basic elements of everything we know. Matter began to coalesce, and gravity came into play, beginning its pull. And slowly, after almost 400,000 years of darkness, the universe became transparent. Light could travel freely for the first time. This primordial light still exists. It whispers to us in the microwave range, faint but eternal. From this point on, structures began to form. Clouds of gas collapsed, forming stars. Stars gathered into galaxies, which spiraled, danced, and collided with each other. From the fiery elements, from chaos, the architecture of the cosmos emerged. Billions of years passed. In one quiet corner, a small star formed, surrounded by dust and rocks. One of these rocks gave rise to oceans, life, consciousness, eyes that looked back to ask, where did we come from? And the answer is that we came from that very beginning, from heat, gravity, and time. From nothing, everything arose. This was not an accident, nor was it a predetermined plan. It was a natural law unfolding on unimaginable scales. And even now, every particle in your body carries a story that began at that very moment. Every breath you take consists of atoms forged in the early fire. You are a remnant of that great beginning. In the early universe, after the Big Bang's flames cooled and plunged into darkness, there were no stars. There was just an immense silent expanse filled with hydrogen and helium. Gravity waited patiently. And then, millions of years after the first light broke free, clumps began to form. Tiny density irregularities, amplified by gravity, drew gas inward, and the universe took its first breath of structure. These clumps compressed, and that's when the very first stars were born. But these weren't the stars we see now. These were giants, true monsters compared to modern stars, tens or even hundreds of times more massive than our sun, burning with a brilliance we can barely imagine. They lived short lives and died young, some existing for only a few million years, mere blinks in cosmic time. We call them population 3 stars, a hypothetical first generation. They were composed of pure hydrogen and helium, the primordial elements forged in the Big Bang. They contained no carbon, no oxygen, no metals. In astronomical parlance, metals refers to all elements heavier than helium. And these stars had none of them. They were truly pristine. Due to their immense size, these stars burned with incredible fury. In their cores, hydrogen fused into helium, and then helium into heavier elements, but their immense weight sealed their doom. Many ended their lives in catastrophic supernovae or collapsed directly into black holes. They left no fossils, no glowing remnants, only their ashes, scattered as heavier elements throughout the cosmos. And it was from these ashes that everything else formed: the carbon in your body, the iron in your blood, the oxygen you breathe. None of this existed before these stars. They created the ingredients of life in their fiery deaths. Without them, no planet could support life. No tree would grow. No conscious being would look up and wonder about its origins. We have never seen any of these first stars. They died too long ago, too far away. Their light may have already faded, or their remnants might be hidden in ancient galaxies, shrouded in dust and distance. But we can infer their existence from what followed: new generations of stars, enriched with heavy elements, galaxies permeated with dust, planets rich in complex chemistry. They were the universe's first alchemists, and the question remains, is even one of them still out there? Could some small star have survived all those epochs and lived to the present day? Ancient and quiet, orbiting in some forgotten corner of the cosmos? If so, it would be older than any star we know, a relic from a time before structure, before light, before the universe as we know it began to form. Once the first generations of stars fulfilled their mission and passed away, the universe transitioned to an entirely new phase of its existence. It was no longer just a vast collection of gas. Now it had its own history, including heavy elements, and an architect named gravity emerged. Gravity acts unhurriedly. It waits patiently, attracts, and creates. Over hundreds of millions of years, tiny star clusters gradually merged, collided, and grew. What began as small groups of starlight eventually transformed into galaxies, vast rotating stellar metropolises. Each is a gravitational cathedral built from the remnants of stellar lives. Galaxies did not arise instantaneously. They formed gradually through collisions and interactions. Early galaxies were chaotic, irregular in shape, representing small groups of stars lacking any symmetry. But gravity was given time. Billions of years passed and smaller galaxies merged, rushing into larger spiral and elliptical structures. Collisions did not lead to destruction. On the contrary, they were creative. Galaxies grew by absorbing each other. Our Milky Way is a result of this process. It did not originate in its final form, but was the outcome of countless mergers, each adding stars, dust, and elements of structure. Even today, it continues to grow. Our galaxy is currently absorbing smaller companion galaxies, such as the Sagittarius Dwarf Galaxy. This cosmic dance never ceases. If we mentally step back and imagine ourselves flying over the expanses of space, below we can see hundreds of billions of galaxies, each containing hundreds of billions of stars. Some are spiral-shaped, resembling spinning tops. Others form giant ellipses, while still others are chaotic clusters. They are not just disparate formations, but form vast networks, connected by invisible threads of gravity and dark matter. Galaxies are not randomly distributed. They align themselves into filaments, forming a cosmic web, a gigantic structure of matter permeating the entire universe. Between these filaments lie vast voids where no luminous object is visible, and absolute darkness reigns. This structure is awe-inspiring, resembling a neural network. Computer models of the cosmic web are strikingly similar to images of brain scans. Billions of galaxies arranged in patterns that reflect the structure of our own thoughts. Perhaps it's just a coincidence, or perhaps not. Within galaxies, stars are born in waves. Clouds of gas compress under their own gravity, forming stellar nurseries. Bright, short-lived blue stars flash, illuminating spiral arms. Over time, the balance shifts, and new stars form less frequently. Galaxies enter a state of quiet maturity. Some galaxies remain small and peaceful, drifting alone in space. Others collide, forming massive slow-motion collisions that stretch over billions of years. In these events, stars rarely collide directly as they are separated by immense distances. However, their gravitational interaction changes everything, triggering waves of star formation, distorting spiral arms, and leading to the merger of black holes. And one day, we will witness this firsthand. The Milky Way is moving towards the Andromeda Galaxy. In about 4 billion years, they will begin to merge, forming something beautiful, not destructive. The night sky will be filled with new arcs of stars, galaxies will coil around each other in a luminous spiral and eventually become one. Such is the destiny of galaxies, not isolation, but union. The cosmos is built through collisions, creating order from chaos, and what began as scattered starlight transforms into a complex structure. The Milky Way, which to the naked eye appears as a soft band of light in the dark sky, seems poetic, serene, and familiar. However, if we could view it from above, we would see a spiral hundreds of thousands of light years wide, rotating like a cosmic whirlpool with 100 billion stars swirling around a hidden center. This is our galaxy, our home, a flattened disk of stars, dust, gas, and memories. We are in one of its spiral arms, known as the Orion Arm, located between two larger arms, Sagittarius and Perseus. This position, modest and distant from the center, is a kind of gift, as it provides us with a clearer view of the galaxy's structure with less interference and a better view of the sky beyond. If we had been born in the crowded galactic core, the night sky might have been a dazzling wall of starlight, beautiful but obscuring everything else. The Milky Way completes one rotation around its axis approximately every 230 million years. This means that the last time the Sun was in its current position in this spiral dance, early dinosaurs inhabited Earth. Stars like our Sun orbit the galactic center at incredible speeds, reaching about 800,000 kilometers per hour. Nevertheless, the galaxy is so immense that it takes them hundreds of millions of years to complete one orbit. At the very center of the Milky Way hides a mystery, a supermassive black hole. It doesn't swallow everything around it, but acts as a central landmark. Millions of solar masses are compressed into a space smaller than our solar system. We cannot see it directly, but we can observe its influence on stars orbiting an invisible point, on matter swirling inward and disappearing, and on radiation reflecting off its boundaries. However, not all of the Milky Way is dense or dangerous. Much of it consists of dust and gas forming nebulae, glowing with starlight, and regions where new stars are born. In these stellar nurseries, gravity compresses hydrogen until nuclear fusion begins and new stars emerge. Some live fast and die, exploding as supernovae, while others, like our Sun, shine stably for billions of years. We are inextricably linked to this spiral, part of its architecture. The atoms that make up your body were once scattered throughout the galaxy, synthesized in different stars, ejected into space, recycled in molecular clouds, and ultimately assembled here, in the form you now inhabit. Even now, the Milky Way is not alone. It is surrounded by satellite galaxies, small companions like the large and small Magellanic Clouds, orbiting it like children around a parent. It is in constant motion, drawn to its neighbors, and eventually destined to merge with the Andromeda Galaxy in a grand collision of star systems. Yet, we see only a part of it. A vast portion of the Milky Way remains invisible, hidden behind dust or matter within which we move. And surrounding all of this is a halo of something else, something that emits no light but binds everything together: dark matter. It holds the galaxy together, shaping its rotation, structure, and ensuring its survival. The Milky Way is not just a collection of stars, it is a gravitational symphony, a blueprint that gave rise to planets, oceans, minds, and questions. In one of the spiral arms of the magnificent Milky Way galaxy, like a ripple in the fabric of creation, drifts a star, unremarkable at first glance. It doesn't dazzle with brightness, nor does it stand out with colossal size. By cosmic standards, it's still quite young, just a yellow dwarf, lost among billions of its kind. And yet, Everything we know, love, and can imagine owes its existence to this most ordinary star. We call it the Sun. The Sun came into being about 4.6 billion years ago. It was born from a collapsing molecular cloud, a simple collection of hydrogen and cosmic dust, set in motion by gravity and perhaps the explosion of a nearby supernova. As the cloud began to contract, its center heated to an extreme and nuclear fusion ignited. Thus, a star was born. But the Sun did not arise alone. A flat disk of gas and dust formed around it. Over millions of years, particles collided and clumped together, forming increasingly larger objects, moons, asteroids, and finally, planets. 8 of these, along with countless smaller fragments, began their orderly elliptical orbits around the Sun. Earth was one of them. Our planet formed from dust and rock, heating under its own gravity. Volcanic eruptions, incessant meteorite bombardments, a fiery beginning. Then, after a collision with another protoplanet, Earth gained its moon, a cosmic twin that became a stabilizing factor. But Earth is unique not only for its geology. It's its distance from the Sun at the ideal range in the so-called Goldilocks zone, neither too hot nor too cold, that allowed water to remain in liquid form. And where there is water, chemistry becomes possible. Over time, carbon compounds began their dance in the oceans, exposed to lightning, heated near volcanic vents driven by time, and a miracle occurred. The first cells appeared. Life, initially single-celled, barely larger than molecules. Then, complexity, photosynthesis, oxygen, multicellularity, eyes, fins, wings, thought, civilization. All of this was fueled by the Sun's energy. Its heat warmed the seas, nourished plants, drove weather, and illuminated the sky. Without this continuous distant nuclear fusion, Earth would have remained an icy, lifeless rock, drifting in cosmic silence. But let's broaden our view. Our Sun is just one of hundreds of billions of stars in our galaxy. And our galaxy is just one of trillions in the entire universe. If this single unremarkable star could give rise to oceans and consciousness, what else might be hidden out there in the boundless expanses of space? What other stars are nurturing their own worlds? What other planets might harbor oceans, continents, life forms gazing at their own stars, wondering if they are alone in the universe? The Sun is our local engine, but it raises questions of universal scale. Its ordinariness makes it extraordinary. For if something so unremarkable can give rise to thought and emotion, cities and language, you and me, then the universe might be overflowing with incredible stories. And we've only just begun to listen. For most of its history, humanity believed Earth was unique, the only inhabited world, the center of everything. Even after we realized the Sun was just one of many stars, we clung to the idea that planets were rare, and life, especially intelligent life, was an accident. But then everything changed. In the 1990s, astronomers began discovering the first exoplanets, planets orbiting stars outside our solar system. At first, they found giants, massive bizarre worlds orbiting dangerously close to their stars, scorching gas balls dubbed hot Jupiters. They were unlike anything in our solar system, exotic yet real. And then there were more, dozens, hundreds, thousands. To date, over 5,000 exoplanets have been confirmed, with thousands more candidates awaiting confirmation. These aren't just statistical anomalies, they're everywhere. It turns out that almost every star in the night sky likely has at least one planet. Many stars have entire planetary systems, some may have dozens. The methods used to find exoplanets are quite sophisticated. We observe stars dimming as planets pass in front of them, blocking some of the star's light. We track the tiny gravitational wobbles they exert on their stars. It's like detecting a moth circling a distant streetlight by watching the light momentarily dim. From these delicate signals, we reconstruct distant worlds. Some are gas giants, others are rocky like Earth. An increasing number of planets are found in the habitable zone, not too close and not too far from their star, where temperatures allow liquid water to exist. We call them Goldilocks planets. Not too hot, not too cold, but just right. These planets keep us restless because every time we find a rocky world orbiting in the right spot, our imagination begins to paint pictures. Could there be oceans, weather, life? Could intelligent beings, cities, civilizations have evolved there? Could someone there be looking into space, wondering if they are alone in the universe? But these are not just romantic fantasies. With instruments like the Kepler Space Telescope, TESS, and soon the James Webb Space Telescope, we are beginning to study the atmospheres of exoplanets to detect the fingerprints of chemical elements, water vapor, and even oxygen. Soon, we may be able to smell the scents of alien skies from light years away. The odds are changing. We once thought we were a cosmic miracle. Now it's beginning to seem that the miracle might be the rule, not the exception. Life may not be rare, but inevitable, etched into the physical laws of the universe, like gravity and light. And if that's true, then the silence of the cosmos becomes even more mysterious and profound. Where is everyone? We will certainly ask that question. But first, we need to grasp the scale we're dealing with. For the nearest potentially Earth-like planet could be 40 light-years away. That's unimaginably close on a galactic scale, yet impossibly far for us. We've talked about exoplanets, about potentially Earth-like worlds in the habitable zone. But now it's time to come back down to Earth. How close are they really? What do these distances mean? Imagine a planet just 40 light-years away. On a cosmic scale, that's practically a next-door neighbor. However, in practical terms, it would take tens of thousands of years to reach it, even with the fastest modern spacecraft. 40 years for light, but tens of millennia for steel and silicon. Yet, 40 light-years is a tiny distance compared to the size of the galaxy, which is 100,000 light-years across. It's like measuring a distance in centimeters on a football field. So in a galactic sense, we're almost neighbors, but practically, we're unreachable. And there are planets 100, 500, 1,000, and even thousands of light-years away. The starlight from them is already outdated information. It's history arriving decades or even centuries after it happened. If you could see something happening there, it might have ended long ago. That's the emotional subtext. These worlds are close in scale, but unimaginably distant in terms of travel. They can be seen, cataloged, their light studied, but touching them is still impossible. And this tension, where space can be both small and vast at the same time, is the essence of cosmic wonder. Hope intertwines with humility here. It's the thrill of unfolding possibilities tempered by harsh reality. And it makes you wonder, what are we to do with all this? Wait for technology to advance? Send signals, build telescopes, trying to hear something? Imagine a future where we travel between stars or seek meaning here and now. Over the next few minutes, these questions will be explored. The silence between the stars will be mapped. We will try to understand what we know about these distant celestial bodies. We will try to illuminate space, time, and possibilities with a narrative torch. For no matter how much numbers speak of distance, stories convey it to the heart. Distances measured, orbits mapped, thousands of distant worlds discovered. Now comes the big question. How do we actually search for life? And not just any life, but life we can recognize. First and foremost, we need to listen to the stars. Natural light holds many secrets, for example, the fingerprints of molecules in the atmospheres of other planets. With powerful telescopes, scientists analyze absorption spectra, looking for biosignatures, oxygen, methane, water vapor. The presence of oxygen can indicate photosynthesis, and in combination with methane, it can point to a chemical imbalance often associated with life processes. Next comes the search for technosignatures, a specific term for signs of alien technology, signals, structures, energy use, and anything that might indicate the presence of intelligence. SETI projects have been scanning the skies for decades, listening for narrowband, repeating pulses, signs of radio transmissions, or beacon signals. So far, no concrete findings have emerged, but the search continues. As for closer objects, our probes and rovers are traversing Mars, looking for plumes on Europa's icy surface and preparing missions to Titan. They are searching for microbial fossils, subsurface oceans, and organic chemistry, all precursors or evidence of life. Each of these efforts is another step towards understanding our place in this world. We're not just asking if there's life out there, but what it will mean for us if the universe is teeming with life, even microbial, or if we are truly alone. The answer to this question will change absolutely everything. If life is common, then the spark of biology connects all worlds. Evolution becomes not just a coincidence, but a universal story. If we are alone, then every living soul, every tree, every ocean on Earth becomes a priceless cosmic anomaly. Whether we find life or not, the very process of searching for it has a profound impact on us. It reminds us that humanity isn't just searching, a part of us desperately needs to. For if we are not alone, then who are we? If we are alone, what responsibility, purpose, and loneliness does that imply? Over the next few minutes, we will explore how these searches are conducted, what has been learned so far, and why nothing is more important than this question. For in the night sky, every distant signal is a question echoing across space and time. Is anyone out there? And our answer to that question may define the history of life itself. In 1961, an astronomer named Frank Drake dared to conduct a bold experiment. He attempted to estimate how many intelligent civilizations might exist in our galaxy at that moment. The scientist didn't claim to know the exact answer, but he proposed a way to frame the question more accurately. His tool was a seemingly simple equation known as the Drake equation. And while outwardly it resembles a mathematical formula, in reality it is a mirror. Each variable in this equation reflects a deep uncertainty and a colossal cosmic mystery. How many stars appear in the galaxy each year? What fraction of these stars have planets? Among these planets, how many can be classified as Earth-like? How many of them are potentially capable of supporting life? Of these potentially habitable planets, on how many does intelligence develop? And of these intelligent civilizations, how many choose to create technologies that allow for communication? And finally, how long are such civilizations capable of existing? The final number is the result of multiplying all these probabilities, multiplied by the unknown. Depending on the values substituted, the result can range from 1 to tens of thousands. And here lies the main difficulty. Even if the emergence of life is commonplace, the development of intelligence may be far less common, and intelligent civilizations may be short-lived. Perhaps most civilizations do not survive long enough to make contact. Perhaps they destroy themselves, or perhaps they simply cease to exist. The last factor, determining how long civilizations send signals, is the most disturbing, because it concerns not only aliens, but ourselves. If we expect other civilizations to exist and communicate for thousands of years, we must ask ourselves, can we survive? The Drake equation does not give us a ready answer. It only provides a framework. It tells us where to direct our search, what we don't know, what matters most, and forces us to confront a harsh reality. Perhaps the galaxy is full of signals, but we have only just begun to pick them up. Perhaps we started too early, or perhaps we are shouting into a void from which no one has managed to escape. Nevertheless, silence is not proof of absence of life. It is a question, a challenge, a heavy stillness that demands we continue to search. Because even one faint signal received from a distant world can change absolutely everything. There's a question that haunts astronomers. A simple, yet profoundly important question. Are we alone in the universe? Not in a philosophical sense, but literally. Out of hundreds of billions of stars in our galaxy, each with its own planets, how many harbor life? And how many of those worlds have built cities, created radio signals, and asked their own questions? In the 1960s, scientists began to break this question down. They tried to trace the path from stars to planets, from planets to life, and from life to intelligence. They used not precise numbers, but filters, probabilities. How many stars form each year? How many of them have planets? How many of those planets are at the optimal distance from their stars, where liquid water can exist, clouds can form, and complex chemistry can arise? Then, how often does life actually emerge? And when it does emerge, how often does it evolve into something conscious, curious, capable of thought, language, and technology? And finally, How long does a civilization last once it reaches a high enough level of development to send signals into space? The truth is, we don't know the answers to these questions. Some of these steps might be relatively easy, while others are incredibly rare. Perhaps life arises quite often, but intelligence almost never. Perhaps intelligence is common, but technology leads to civilizations destroying themselves. Or perhaps all these civilizations exist right now, but they are too far away, sending signals too faint, or emerge too early or too late. It's like tuning an old radio, trying to catch a faint whisper in a galaxy full of silence. And the numbers we plug into the equation are like a mirror. Plugging in different values yields vastly different results. One estimate suggests millions of civilizations could exist in the galaxy. Another estimate suggests we might be utterly alone. But here's the point. Even the existence of just one other civilization would change everything, because it would mean we are not an accident, that the universe favors the emergence of life, that we are part of something larger, a cosmic ecosystem, a community we have yet to meet. And if we are indeed alone, then this tiny blue world, this flickering spark of self-awareness in a cold and dark sea of cosmos, becomes infinitely precious. Either way, this question matters immensely. It reveals who we are, what we fear, what we hope for, and perhaps what awaits us in the silence of space. So we've peered intently at stars, planets, vast cosmic distances, and even silence itself. But there comes a moment when the questions demanding answers become so grand that they don't allow us to stay put. And that's exactly where we are now. For if we accept that the universe is ancient, teeming with stars and planets, yet maintains absolute silence, perhaps the root of the problem lies not in external factors, but within ourselves. Perhaps our assumptions are wrong, and the universe is structured entirely differently from what we've come to believe. Let's start with one of the most incredible hypotheses. What if we live inside a computer simulation, not just metaphorically, but a genuine programmed construct? If reality is computational in nature, like a game or a laboratory experiment, then the reason we can't detect other civilizations might be that they were deliberately removed, hidden, silenced, or perhaps never even existed in this simulation. Some learned scholars argue that if any civilization reaches a level of development allowing it to simulate entire universes, then most intelligent beings would likely reside within such simulations. And if that's truly the case, how can we know? Here's another version. Alien civilizations might be deliberately invisible, not due to weakness, but on the contrary, due to excessive strength and power. Highly advanced species might operate on scales or frequencies that we simply cannot detect. They might use quantum networks, gravitational waves, or particle fields. They might be all around us and we wouldn't even suspect it, or they might be deliberately hiding from us. If the dark forest theory is true, where shouting your existence into space is extremely dangerous, then concealment becomes the only way to survive. These silent civilizations might still exist, observing us and biding their time. There's also the so-called zoo hypothesis, which suggests that Earth is deliberately avoided by other civilizations. Intelligent beings might exist, but they have chosen not to interfere with our lives. For them, we are merely animals behind glass, inhabitants of a cosmic preserve. But there's also the most unsettling explanation. Perhaps we emerged too early. Perhaps life, intelligence, and even curiosity are only just beginning to blossom in the universe. Perhaps the universe simply needed time to mature. Perhaps the conditions suitable for the emergence of consciousness are only now forming, and we are among the first sparks of intelligence. If this is indeed the case, then we are not only pioneers, but also guardians. We bear the burden of being the only voice that can currently speak on behalf of the cosmos. These explanations might sound like science fiction, but in reality, they are not just wild conjectures. These are carefully developed models, thought experiments, philosophical weapons designed to break through the veil of mystery surrounding the cosmic silence. And all these theories share a common thread. They shift the focus from what's out there to who we truly are. Perhaps the silence of space is not an emptiness. Perhaps it is structured, designed, contains glitches, or is only just beginning to awaken. And in the absence of a definitive answer, we are left alone with the haunting thought: the universe is either teeming with life, or we are utterly alone in it. And either way, the consequences of this discovery will be staggering. We have spoken of stars, of galaxies, of the visible and luminous cosmos, but most of the universe remains inaccessible to us. Not in the sense that it has disappeared, but in that it is hidden from our eyes. It is silent. It emits no light, reflects none, and gives off no heat. And yet, it exists, holding all cosmic objects in their places. We call it dark matter, and it is not just some space filler, but a vital component of the universe. Without dark matter, galaxies would simply fly apart, and stars would scatter in all directions like sparks from a grinding wheel. But this doesn't happen. Galaxies are held together by an invisible, massive halo surrounding them. We have managed to map dark matter, albeit indirectly, by observing the rotation of galaxies, how light bends around galaxy clusters, and how the cosmos expands. Dark matter is always present, leaving a gravitational imprint, yet remaining invisible. What is it? We don't know. It is not made of atoms, dust, or gas. It does not behave like anything we have ever seen in a laboratory. It is matter, but it does not interact with light. We cannot see it, but we can only observe the results of its effects. But that's not all. If dark matter holds galaxies together, something even stranger is, on the contrary, pushing them apart. This is dark energy, which, unlike dark matter, which exerts attraction, expands space. Dark energy is the cause of the accelerated expansion of the universe, which causes distant galaxies to move away from us faster and faster. It is a kind of anti-gravity, acting not just in space, but on space itself. Together, these two mysterious entities, dark matter and dark energy, make up more than 95% of the universe. Just think about that. Everything you have ever touched, tasted, built, destroyed, or loved, all the atoms that make up every star, every world, and every form of life, constitute only the remaining 5%. We are merely shadows, dancing in the light of a deeper and unknown reality. And yet, using these 5%, we have begun to map 95% of the universe. With telescopes, complex mathematical calculations, particle collisions in underground laboratories, and computer simulations run on the most powerful supercomputers, we are gradually forming the outlines of an invisible world. The universe consists not only of what we see, it consists of what holds all objects together and of what tears them apart. And once you realize this, everything changes dramatically. You begin to ask entirely different questions. Not just, what is there? But why does anything exist at all? Why is there something rather than nothing? What lies at the core of reality itself? In previous chapters, we delved into space, measuring distances and discussing the universe's expansion. However, there's another dimension that has subtly accompanied us throughout this time itself. We constantly perceive its passage and maniacally try to measure it. But what is time, really? We tend to think of time as a river, flowing relentlessly forward. However, physics suggests it's more like a dimension, similar to those that allow us to move left and right, up and down. We move through time just as we exist in space. Nevertheless, our movement is restricted to one direction, forward, always forward. But why? What prevents us from moving backward? Why does time, it seems, flow? One possible answer lies in the concept of entropy. Entropy is the idea that any system tends toward greater chaos and disorder over time. For example, a glass breaks, but never reassembles into its original form. Smoke disperses into the air, but never gathers back into a dense cloud. Entropy always increases. And this isn't just a tendency, it's a fundamental law. It is the increase in entropy that gives us the so-called arrow of time, pointing from past to future. But here's the catch. The laws of physics don't care which direction they go. They work equally well in both forward and reverse. Even if we showed a film of particles moving backward, they would still obey all known equations. Time itself, in a mathematical sense, has no preference. So where does the arrow of time come from? Perhaps it originates in the Big Bang, the moment of the universe's birth, when everything was in a state of extreme order that has been steadily decaying ever since. Time, as we know it, may simply be an echo of the universe's birth. But time is a flexible concept. Albert Einstein showed us that time is not constant. It can stretch, slow down, and curve under the influence of gravity. The stronger the gravity, the slower time flows. Near a black hole, seconds can stretch into centuries. Time and space are parts of the same fabric, the so-called space-time continuum. You don't just move through space, you glide through time. And at the speed of light, time virtually stops. A photon, from its perspective, never ages. It is born and absorbed at the same moment. For light, the universe has no duration, only a position in space. Time is not a universal concept. It is subjective. Your personal time depends on your speed, gravity, and motion. You and I age differently if we move differently. And this isn't just a theory. It has been proven with satellites, atomic clocks, and particle beams. So, what is time? A measurement, a metric, an illusion, a direction, a mystery. And throughout all this, there is one thought that lingers. If time had a beginning, can it also have an end? Are there places, moments, or phenomena where time breaks, stops, or loops? Is the future predetermined, or is it still being created, second by second, thought by thought? Or are we just passengers, unable to get off this ride? So far, we've mapped distant galaxies, measured stars, warped space, and stretched time. But behind every fact, every number, and every question, something silently observes. Your consciousness is the only thing we can be sure of. Not the stars, not the atoms, not even time, but simply this. You are aware of yourself. You are not the entire universe, but somehow a part of it has become you, capable of asking questions about itself. And this is strange because physics cannot explain consciousness. It explains neurons and electrical impulses, but the experience of being, having thoughts, memories, fear, and love, that is something else entirely. Let's pause here. Truly pause. Right now, you are listening to a voice in your head, a story. But who is listening? Who are you behind your eyes? This question, what is consciousness, is not just philosophical. It's a scientific mystery. Because we don't know where it comes from, how it arises, why a brain, properly structured, suddenly stops being just a machine and becomes a mind. Perhaps it's an emergent property, like a pattern, or fundamental, like mass. Some even suggest that consciousness is woven into the fabric of the universe, like space and time, and that the universe itself needs consciousness to exist. But here's a truly eerie thought. If the universe is 13.8 billion years old, and if life emerged only on our tiny planet and consciousness appeared only recently, then it means that for almost all of that time, the universe existed in silence, without thought, without awareness, without reflection, just stars collapsing and exploding, and no one noticing. Until, after billions of years, the universe produced a being capable of looking at itself, measuring itself, and asking questions about itself. You are not just in the universe, you are the only known window through which it can see itself. And that makes you incredibly rare. Perhaps not unique. Perhaps there are others, other eyes, other questions, other dreams, but so far we haven't seen any. And that means your mind means far more than we could ever imagine. Who are you really? Not your name, not your face, not your history. Strip away memories, language, and culture. What remains? Just a flicker of awareness, a silent observer, that which within you knows it is here. That is I. But where does it begin, and where does it go? In a universe of stars and entropy, black holes and red shift, the strangest thing might be the mind that knows it is temporary, aware of its own end. No star knows it is dying, no planet grieves, but you do. You know that time passes, that you will not live forever. You feel it. And this knowledge, the awareness of impermanence, is the price of consciousness. It hurts, but it also creates meaning. Death is not just an end, it's a frame that makes every moment sharp, beautiful, and urgent. If we lived forever, Would anything matter? And yet, the mind rebels. We fear death. We fight it. Every story we have ever told, every religion, work of art, and scientific discovery is, in some way, a reaction to the fact that we are conscious and finite. But here's a strange twist. Everything you've ever been is made of atoms, ancient atoms. The hydrogen in your body was forged in the Big Bang. The carbon in your bones was created inside stars. You are made of dead things, and yet somehow you are alive. And when you die, these atoms will continue to exist. They will not disappear or stop. They will return to the cycle, from dust to dust, from thought to silence, from silence to stars. So perhaps consciousness is not something that is lost, but rather a pattern that emerges when the right conditions blossom. A wave, not a particle, a ripple in complexity. If this is true, then death is not an erasure, but a liberation. And the universe, vast, dark, and expanding, may be capable of producing that flicker again somewhere else, in someone else, or perhaps in some new form beyond anything we can comprehend. But for now, you are the only evidence we have. You are a miracle in mathematics, a fragile pulse in an indifferent cosmos. And perhaps that is enough. Humanity has stopped dreaming of distant stars and immeasurable distances, turning its gaze to more intimate questions, to the inexpressible weight hidden behind every search for meaning. For, having understood the grandeur of the universe, the rarity of life, and the fleeting nature of consciousness, the question inevitably arises: does anything matter at all? What good are kindness, beauty, and thought in a boundless cosmos destined to cool? Why care about joys, sorrows, and art when even stars are doomed to perish? What is a fleeting breath worth compared to trillions of empty worlds where no breath has ever sounded? This is the abyss of cosmic melancholy, a chasm where all meaning seems to drown. The silence of the universe is not just a physical phenomenon. It is a profound, emotional emptiness. We cry out for significance, but the cosmos remains silent. And yet, despite everything, we continue to love, to dream, to look at the sky, mesmerized not by fear, but by wonder. And perhaps therein lies the answer. Perhaps meaning is not to be found in the universe, but to be brought into it. Perhaps our purpose is not to find a purpose, but to create one, to fill every crack with it, to fiercely erect it, like a fire in the darkness. The fact that the universe does not give us ready answers is our greatest strength, for it means that the choice is ours. We ourselves determine what matters, who we are to be. We are not here to be judged, but to fill the world with meaning. And look what we have created with this freedom. We composed symphonies, fell in love, painted stars. We sent robots to other planets, found cures for diseases, held the hands of the dying, wept over poetry. We took the chaos of physical laws and transformed it into compassion. No other creature, as far as we know, is capable of this. And what if meaning is so rare? Gold is also rare. Light in deep space is rare. And you too are unique. The universe is not obligated to give us purpose, but we, against all odds, give it to her. And that changes absolutely everything. We build, we speak truth, we love, and we inevitably ask, how long will this last? This question, like a shadow, accompanies every creation, every sculpture, story, whisper in the night. It's a quiet rebellion against inexorable time. For deep down, we know that everything will eventually fade. Empires will crumble, stars will die, even memory will be erased. The universe obeys entropy, the great destroyer. It relentlessly dissipates energy, destroys structures, equalizes temperature. That's why ice melts, flames die, no mechanism works forever, and ultimately, the universe itself may plunge into cold and darkness. But despite this, we build pyramids, create golden records for Voyager, compose songs passed down by word of mouth, create digital libraries encrypted in crystals, send binary messages drifting from the solar system into the boundless void. Why? Because even without being able to stop time, we can leave our marks in it. Not eternal, but long enough to echo, to reach into the future, to remind some distant intelligence, or perhaps just the void, that we existed. We thought, We dreamed. We strived. There is a strange grandeur in this. Recall Voyager 1, launched in 1977. It is now more than 14 billion miles from Earth. It carries images, greetings, music, a time capsule sent into the utter darkness. It will drift among the stars for billions of years, outliving both Earth and the extinguished sun. Perhaps it will never be found. But that doesn't matter. What matters is that we sent it, that we declared our existence, that we tried. So what remains after us? Not buildings, not even species, perhaps stories, perhaps acts of care, perhaps the urge to create beauty despite awareness of its impermanence. And even if all this disappears, if entropy devours every word, every memory, every work of art and architecture, then perhaps the most important thing is that it all happened at all. We lived, we thought, we burned with consciousness in a universe that did not ask us to. And that is no small thing. For centuries, humanity has gazed heavenward, gripped by the same question. Is there anyone out there in the boundless expanse of space looking back? This isn't just about stars or planets, but about intelligent beings possessing consciousness, history, and the ability to ask questions, beings whose gaze might meet ours. This is the eternal hope of all who ponder cosmic existence, the hope that we are not alone in the universe. But what would a real encounter mean, not with microscopic life forms or fossils, but with a civilization, with an intelligent species aware of its existence, having created tools, language, and perhaps even its own traditions? Perhaps members of this civilization, like us, gazed at their own night sky, pondering the very same question. We often imagine first contact as a scene from a science fiction movie. Spaceships, greetings, mutual understanding through translators. However, the truth will likely be far more unusual. If we ever receive a message from alien intelligence, it will most likely be a signal, a pulse, a stream of data sent in the distant past across immeasurable light years. This signal might come in the form of radio waves, a laser beam, or a burst of neutrinos. By the time it reaches us, its senders may already have ceased to exist. Nevertheless, we will undoubtedly undertake its deciphering, analysis, and study with the utmost diligence. For even a tiny fragment, a word, a number, or a pattern will be of immense significance. It will be proof that we are not an accident, some cosmic anomaly. It will connect us to something greater, older, and existing in parallel. And yet, there is also something sobering in this dream. If an alien civilization proves to be more advanced, the gap between us might be insurmountable. We might be like ants trying to understand a broadcast from a vast cathedral. It's quite possible that we won't even be able to recognize language or meaning in their message. And if they turn out to be less advanced, if we discover only ruins, echoes, or faded signals, then we will become the elder voice, the keepers of their memory. In any case, such contact would fundamentally change everything: our religious beliefs, scientific knowledge, understanding of life, purpose, and time. We would cease to think in terms of individual countries or peoples and begin to perceive ourselves as a single species whose voice echoes among the stars. Even the attempt to make contact is of immense importance. Projects like SETI, Search for Extraterrestrial Intelligence, METI, Messaging Extraterrestrial Intelligence, the creation of the Golden Records, and the sending of beacons into deep space are not just attempts to find aliens, but acts of self-definition. What would you say to someone you've never met? What would you send into the starry depths? Perhaps music. We continue to ask questions and reach for the stars. But what if no one answers? What if we send messages, launch telescopes, and scan the heavens for centuries, hearing nothing but the quiet hum of physical processes? No contact, no signals, no ruins, just all-encompassing silence. In such a situation, it's easy to fall into despair, to imagine a lifeless cosmos, cold and indifferent, to believe that we are alone, lost on a tiny blue island, surrounded by an ocean of stars that will never speak to us. However, perhaps we are looking at the situation from the wrong angle. Perhaps silence is not a refusal, but an invitation. If we truly are the first or only species to awaken to consciousness, then we are the very voice the galaxy has been waiting for, a story that is only just beginning to be written. We are the torchbearers in a universe not yet filled with song. This means that this moment, our time, carries an unimaginable responsibility, because our future actions will matter immensely. Will we withdraw into ourselves, divide and destroy ourselves, never leaving the cradle? Or will we strive for the stars, build, explore, learn, and manage to survive long enough to become those who send messages to future intelligent beings? Imagine this. 1,000,000 years from now, a young species, just learning to listen, picks up a signal, ancient, simple, and unequivocal. You are not alone. We were here, and we made it. This signal could very well have been sent by us. We could become the first page in the book of galactic civilization, a myth, a memory, a voice that survived time. And if such a possibility exists, even the smallest, then our task becomes clear. We must earn our place in history, not only through technology, but also through wisdom, kindness, art, music, and science. All that makes consciousness beautiful. For if we are first, then we set the tone. The cosmos does not give us purpose, but it gives us time, space, and silence. And how we use that silence is entirely up to us. We often imagine the future as tomorrow or next year, perhaps looking a century ahead. But what about 1,000,000,000 years? What will the universe look like then? Not for us, but for time itself. Let's start with the stars. Our sun has about 5 billion years left to exist. After that, it will swell into a red giant, then collapse into a white dwarf, a glowing ember slowly fading into darkness. Other stars will meet the same fate. Massive ones will explode as supernovae, leaving behind neutron stars or black holes, while smaller ones will quietly fade. In trillions of years, the night sky will become dim and lifeless. Galaxies will also undergo changes. They will collide, merge, transforming into enormous elliptical structures. The Milky Way and Andromeda will unite into one, a gigantic silent vortex of aging stars. Eventually, star formation will cease. The raw materials, gas and dust, will be depleted, and no new stars will be born. Then, the universe will enter the degenerate era. Black dwarfs, neutron stars, rogue planets, drifting between dead suns, will turn into a cold, lifeless graveyard of what once existed. But the story won't end there. Over unimaginable spans of time, even these remnants will disappear. Black holes will evaporate via Hawking radiation, slowly losing their mass over quadrillions of years until no trace of their gravity remains. And then there will be only darkness, the absence of stars, light, and energy. Just a rarefied cold fog of particles stretched across an ever-expanding void. This is heat death, the universe's final breath, the absence of chaos and fire, just stillness, maximum entropy, and perfect silent equilibrium. It is difficult to imagine and even harder to accept. A place where even memory fades, where time itself continues its course, but nothing happens. And yet, we, on a tiny planet in a young universe, contemplate its end. This is a true miracle. For even if the future is bleak, we are the light in the present. We are meaning, movement, and music. And perhaps that is the essence, to burn brightly, perhaps not forever, but fiercely, to be conscious while the universe is still young enough for it to matter. We are not the finale, but only the first act. The first act is complete. So, we have journeyed to the very edge of creation. We have witnessed the demise of stars, the fading of distant galaxies, felt time slow its pace, striving for a complete halt. And now we return to the present, to you who are sitting here now, breathing, listening, living. The universe is completely indifferent to what you do. It will not punish or reward you. It will not applaud your ambitions or mourn your mistakes. But you care. And that changes everything. For if all that exists, stars, atoms, consciousness, language, is truly temporary, then you are the most unique phenomenon in the entire universe, a being aware of its own finitude. And here's the truth. The grandeur of the universe does not diminish you. On the contrary, it elevates you. The fact that you are so small gives your decisions incredible power. The fact that your lifespan is so short makes every moment precious. Every act of kindness you perform, every word of truth you utter, every life you touch, every work of art you create is born in defiance of cosmic silence. It's like a bright flash, a unique imprint, a wave of purpose in the boundless ocean of indifference. And perhaps that is what makes us special. Not our understanding of how the universe works, but our care for it. We give names to stars. We build telescopes to see light coming from galaxies 13 billion light years away. We fall in love looking at the starry sky. We send poems into space. We feel awe. We have been among the stars, drifted beyond galaxies, stood at the very edge of time. But now we are back on Earth. The air around us is warm. Our chests rise and fall rhythmically. Our hearts beat again and again. And suddenly, the question of how the universe is structured recedes, giving way to the question of how we will use the tiny part of it allotted to us. For here's the truth. We live in a universe whose age surpasses all comprehension. It is constantly expanding, cooling, and gradually moving towards a state of stillness. But in this brief moment, you are alive. You are matter capable of feeling. You are a pattern aware of itself as a pattern. The stars created you. Yes, but now you can look at them and whisper what they never can. I understand. So what do we do with all this? Create, destroy, or dream? Withdraw into ourselves, consumed by our own insignificance and struggle for survival? Or strive for knowledge, empathy, and understanding? The universe doesn't care. It has no preferences. But perhaps we should. Perhaps the meaning of our existence lies not in the stars, but in what we choose to cherish and what we dream of. Perhaps the purpose of intelligent life is not to exist forever, but to create something worthy of memory before it vanishes. For if we are truly alone in the universe, if no one is watching us and no signal will ever come, then everything we do takes on even greater meaning, not less. Every act of kindness, every scientific discovery, every poem, every moment spent together under the starry sky. These are not just trifles. They are all we have. They are the only parts of the universe that are aware of their existence. So perhaps in the end, the question isn't how vast the universe is. Perhaps the question is how great your response to it is. You have this one life, this one mind, this one chance to be a spark in the darkness. And you are not alone. We are here too. We think, we ask questions, and we strive for more with you. Let's revisit that absurd yet memorable phrase. You might think the pharmacy is far away, but that's minuscule compared to cosmic scales. At first, it seemed funny, a kind of cosmic joke. Now, it sounds like an understatement because, by exploring the boundaries of time and light, investigating the structure of galaxies, traversing black holes, and delving into the depths of consciousness, we arrive at an undeniable conclusion. You are tiny, but this is not a humiliation, it's a revelation. Your significance is determined not despite your size, but precisely because of it. For in this boundless and indifferent space, you care. You search, you wonder, you ask questions that no other creature, no star, no atom has asked. And somewhere in this process, the scale shifts. The road to the pharmacy transforms into something beautiful. The mundane becomes sacred. The morning sunbeams touching your skin are not just a weather phenomenon. It's a star 150 million kilometers away, filling your cells with energy created in its nuclear heart. The water in your glass is ancient hydrogen, born from the Big Bang. The iron in your blood is stardust, formed in a supernova explosion. Your breath is recycled stardust. Everything around you is vast, but you are aware of it, and that changes everything. We drift away not to lose ourselves, but to understand where we truly are. Not at the center, not above or below, but within. The universe is not just a place where we live. It is what we are a part of, and a part of ourselves. So, the next time you walk down the street, look up. Not in search of answers, but for context. You are not just moving through a city or a planet, you are moving through a living miracle, a brief flash of thought in a universe that is mostly silent. But perhaps, just perhaps, it is listening now. All our inquiries, whether studying stars, atoms, galaxies, time, or life itself, inevitably lead us to the threshold of wonder, not the boundary of knowledge. For knowledge has its limits, while wonder is boundless. Now you know the basic facts. The universe is 13.8 billion years old. It is constantly expanding. It is colossal in size, characterized by low temperatures and filled with darkness. We ourselves are woven from stardust. Our existence is fleeting, yet astonishing. However, these facts are not the conclusion, but merely a starting point, a door to the unknown. Beyond all the data, beyond all the theories and amazing discoveries, something more remains. A silence that no formula can explain. A grandeur hidden behind the stars. A feeling of incompleteness, even with all our knowledge. And it's not that the universe owes us ready-made meaning, but our insatiable need to seek it. Perhaps this is the main paradox of our existence. We are beings evolved for survival, nourishment, movement, and reproduction. And yet, we ponder infinity, yearn for the stars, marvel at the sight of galaxies, and strive for connection with what we have never seen. We are born for breath and heartbeat, but we crave eternity. And this craving, this desire to go beyond the necessary and the explicable, is perhaps the most incredible manifestation of the universe. It has given birth to something capable of asking questions. And here's the unexpected twist. Every time we approach an answer to one global question, for example, about the size of the universe, another, even larger one arises in its place. What was before it? Why is there something rather than nothing? What lies beyond space and time? Where does this edge end? No one knows. Perhaps no one ever will. And perhaps that's for the best, for it is mystery that drives our development. What matters is not only the size of the universe, but the scale of the questions it leaves behind. We are not lost in cosmic space, but illuminated by it, if only for a brief moment, now. And perhaps this is the only thing the cold and expanding void cannot create on its own. Wonder. So what do we do next? Live, create, connect, tell stories, build bridges, ask questions no one dares to answer. Be kind, not because the universe demands it, but because it is our conscious choice. And when you look at the stars tonight, don't feel small and insignificant, but feel your uniqueness, your transience, your ability to be aware. This is your moment. This is your chapter in the cosmic book, and no one but you can write it. Let's put aside the calculations. No more distances, timelines, or divisions. Just this. You are here now. After 30 chapters dedicated to stars and silence, equations and awe, the mind is overflowing. But deep down, something more awakens. Not just reflection or understanding, but a special state of peace, a soft response in the chest. For you have felt it already, haven't you? The truth hidden behind every number. This wasn't just a documentary, it was a mirror. And looking into it, you saw something more than the universe. You saw yourselves. You are small, but not meaningless. You are temporary, but not insignificant. You are a spark of consciousness, so brief and fragile, yet carrying questions capable of echoing in the deepest depths of the cosmos. In a universe where galaxies are born and die unnoticed, you noticed. And that alone is incredible. So here, at the edge, we leave you without definitive answers, but with a sense of tension between fear and wonder, with a silence that cannot be explained, with tears you didn't expect, and perhaps with a smile. For the meaning of this story was not to explain the universe, but to remind you that you are an integral part of it, a rare and fragile voice in a vast and ceaseless song. And yet, you sing. There is a boundary that cannot be crossed, yet it defines all our knowledge. It is called the cosmic horizon, the edge of the observable universe. This is not a wall or a place one can travel to, but a limit, a boundary determined by light, time, and the very speed of causality. It is the maximum distance that light has had time to travel to us since the birth of the universe, approximately 46 billion light-years in all directions. This number seems definitive and precise, but it is not. For beyond this edge, beyond the visible, lies something we cannot yet see or measure, but almost certainly know exists. More stars, more galaxies, more matter, more space, and perhaps even more versions of reality. This is the most challenging concept to grasp. What we have seen, mapped, photographed, and modeled, what we have touched with radio waves and telescopes, that's not all. It's just the very beginning, a grain of sand on a beach of unknown size, a dewdrop on the edge of a cosmic storm. What lies beyond? No one knows. Perhaps it's more of the same, endless expanses of stars and voids, clusters and filaments, repeating endlessly. Or perhaps something stranger lies there, regions with different laws of physics, different particles, and different versions of causality. Perhaps the universe is curved, folded, and connected to dimensions we cannot perceive. Or it might suddenly and unimaginably end. But there is a deeper truth. The edge we speak of is not only physical, but also philosophical. For the observable universe is not only the limit of what we can see, but also the boundary of our knowledge. And standing at this edge, we face a question that haunts all thinking beings. Is this all? Is this all we can know? Or is there something beyond the unreachable, the unknowable, yet still real? This question challenges not only science, but also our humility. For we must learn to live with not knowing, to breathe in mystery, and to reconcile ourselves with limitations. But it is in this humility that beauty lies. We become explorers again, not of lands and planets, but of questions, meaning, and curiosity itself. And perhaps this is our main purpose, not in the answers, but in the striving for them, in wonder and dissatisfaction. We stand at the edge of the visible universe not with maps, but with imagination. And for now, that's enough. There's one question everyone carefully avoids, and it's not because it's forbidden, but because no data, however extensive, can answer it. It's not about distant galaxies or tiny atoms, not about colossal distances or relentless time. It's about what lies beyond the known, beyond our understanding. We've traveled billions of light years through this story. In our minds, we've turned massive stars into singularities, warped the very fabric of space, traced the fleeting breath of consciousness, and faced the inexorable end of time. But ultimately, every map ends in uncharted territory, marked not by precise coordinates, but by ringing silence. And in that silence remains something, the final, insoluble paradox. For the more we learn, the further we advance, measure, discover, and comprehend, the more acutely aware we become of how little we truly know. The horizon constantly recedes, but we can never reach it. Every answer gained gives rise to an even deeper and more complex question. Every scientific breakthrough reveals an even vaster and more terrifying unknown. What is this feeling? This poignant longing in the chest? This deep stillness that is not complete tranquility? This tremor at the very edge of understanding? It is awe, but it is also fear. For if the universe is truly infinite, then so is our insignificance. But if it is finite, then our meaning is also limited. If we are utterly alone, then we are inexpressibly precious. If not, then we are just one quiet voice in a vast choir that we cannot hear. Either way, this truth is both unbearable and beautiful, and its echo will resonate within us endlessly. What created the universe? Why does it exist at all? What is the origin of the fundamental laws governing everything we have ever seen? Is there something beyond this, something beyond existence itself? We don't know, and perhaps we never will, but we continue to ask these questions. And perhaps that is the whole point. For in a universe filled with blind, ruthless forces and indifferent stars, it is you who ask the impossible questions, dream, grieve, create meaning from a simple cloud of dust illuminated by nuclear fusion. You don't just exist. You ask why you exist. And that, perhaps, is the most powerful force in the entire universe. You are not the culmination. You are rather the continuation. A story that refuses to end, even when the last page becomes unreadable. A faint light that will burn, ask questions, and strive forward no matter how dark the night becomes. So here, at the very edge, we leave you not with a final period, but with a pregnant pause. Because the greatest question the universe asks us is one it will never answer. And perhaps that is the most human thing about it. To stand at the very edge of eternity and ask again, what else is out there? The screen goes dark. No more bright images, no complex numbers, just the sound of your own breath, and the universe is still here, humming beyond your comprehension. You have come an incredibly long way. And not so much in physical space as in something far deeper. You have expanded the boundaries of your mind, stretched your imagination to the very edge of time, faced mortality, unfathomable mystery, the unbearable size of everything. And somehow, you are still here. Not broken, not lost, but wider, deeper. That's what a true miracle does. It doesn't give simple answers to questions. It only deepens them, makes them more complex. It doesn't bring long-awaited peace. It opens you to new experiences. The greatest gift of the universe is not knowledge itself. It is a unique perspective. You are here for only a fleeting moment, and yet, somehow, this moment contains entire galaxies. You are made of fragile flesh and neurons, and yet you hold within you stories that even the stars cannot tell. The universe does not exist for you to conquer it, but for you to witness it, to marvel at it, to carry it in your heart like a secret, cherished fire. And perhaps, if you are lucky to pass it on, for true wonder is contagious, it echoes in other hearts. Questions live much longer than answers. So share this feeling with others. Tell someone, not just the dry facts, not just billions of light years or dark matter or entropy. Tell them what it's like to be small, aware, to be a question walking through the impenetrable darkness. But for now, we will rest. You are not in the universe. You are not separate from it. You are the universe itself, asking itself what it means to exist. And that question is still unfolding, revealing itself to us. Friends, thank you for your attention. See you in the next video.